Accepted theories of time travel usually rely on the physics of relativity, the complex bending of spacetime, or the stabilization of wormholes. In a simulative universe, these physical mechanisms disappear. This matrix compares the two perspectives. Within a simulated reality, temporal transit is a question of database permissions. The diagnostic conclusion confirms the shift. Navigating a simulated timeline requires managing processing limits and read-write access protocols. We have to treat the universe like an operating system. This allows us to run a penetration test against the reality engine to see if a temporal exploit exists in the underlying code. Temporal movement within this system depends on identifying a specific system vulnerability. We initiate the first attack vector. We target ancient Egypt to observe the construction of the pyramids. The system blocks the request. The red dividing line indicates the Renaissance boot, powered on during the 16th century. The left side shows everything prior is procedural backstory, a 2D flat database providing logical context. This log illustrates the failure. Because the 3D mesh is missing for this era, attempting to travel to the Roman Empire results in jumping into an uncompiled void. The physical geometry never existed. The digital query overlay on this manuscript clarifies your permissions. You are granted read-only access. You can search the historical lore like a static text log file, but you cannot physically interact with it. Physical interaction is impossible in an era that the computer never calculated in 3 dimensions. We adjust our target to the 19th century. This era is well past the system boot date and was actively rendered by the engine. The engine denies the request. Moving one human backward requires reversing every other entity on the planet. Step 3 explains this block. It requires a global server rollback to load an old save game. Localized avatars lack admin rights to overwrite the global database. The reality engine interprets the grandfather paradox as a catastrophic database integrity bug. The warning flags on this error log show the system response. The reality engine locks historical save states to prevent users from generating invalid causality loops that would corrupt the global dataset. The core system explicitly blocks all visits to the recent past to protect the current simulation from user-generated corruption. With the past locked out, we conquer target 500 years forward. Here, we encounter the real-time render horizon. This wireframe on the right illustrates how the simulation computes the world frame by frame, based strictly on present variables. A forward jump forces the engine to instantly calculate trillions of future variables. The resulting CPU overload ejects the traveler into the null space, an uncompiled void devoid of physics. The system confirms that no physical map of tomorrow exists. As these probability curves illustrate, prophecies are simply outputs generated by the simulation's predictive AI models. Forward travel fails because the future is a blank data state waiting to be compiled. While active jump vectors fail, the penetration test reveals one verified vulnerability. It requires a passive approach. The exploit is Suspend-to-RAM. Entering cryostasis removes the avatar's instance from the active calculation cycle. The simulation core processes billions of world state frames while the avatar remains paused. Finally, the user wakes up in a future render state, executing a massive frame skip. The executive summary on the right details the final state of the engine. Antiquity is read-only lore. The recent past is locked behind admin rights. The future is uncompiled code accessible only through frame skipping. Processing power is the only true barrier to the future. You simply sleep while the reality engine handles the heavy lifting.